Watch what you say. Thank you. Take your hat off, please. It's a cinch. So, like I said, we're starting chapter 11. What we're going to be doing is we're going to talk about three very important things. The first thing that we're going to talk about is something called the fundamental counting principle. Anybody ever heard of the fundamental counting principle before? Yeah. Cool. So let me write it up here for you guys. Fundamental counting principle. I hope I spelled that right. Is it PLE? Too late. Too late. I think that's principal, like high school principal. Principal should be PLE, right? Okay. So, let's talk about the fundamental counting principle. Whenever I hear about the fundamental counting principle, I always remember this old Subway commercial. You know what I'm talking about? Not the Dairy one. There was this commercial where they were like pushing all their sandwiches. They're like, oh, we've got like so many sandwiches that you can choose from. Like we literally have like hundreds of sandwiches you can choose from. And I'm like, I've been to the Subway. There's not very many options. And you're talking about hundreds? Well, technically, yeah. If we get into the fundamental counting principle, and we agree on some things, would you agree that if I have a sandwich, two sandwiches, yeah. One has mustard, the other one does not, they are not the same sandwich? Yes. Then we agree. Yeah. Fundamental counting principle says that if one has mustard, now you've changed it, it's a different sandwich. Okay? So with that idea in mind, we were checking out how many different items they had over at Subway here. They had 9 different breads. That's a lot. I don't even know if you included the brown ones. You guys remember brown sandwiches? Yeah. But anyways, it's those. They've got flatbreads in there. They got 6 different cheeses, 15 different meats, 19 veggies, 17 dressings. That's a lot of different stuff, right? So, how does this translate into hundreds of sandwiches? Fundamental counting principle says, if some event happens X number of times, and another event happens X number of times, then the number of different things that you can combine there is X times Y different events. So here's what we're going to do with this. If there are 9 different I'll just change my color here. If there are 9 different types of bread, 6 different types of cheeses, 15 different types of meats, 19 different types of veggies, and 17 types of dressings, times 2. Thanks to someone in my 3rd hour, because you can also get it toasted and not toasted. And that makes a difference, especially if we talk about chicken sandwiches. Yes. Gotta be toasted. Got to be toasted. So I'm going to find this product. I'm just going to use my handy dandy calculator here. I'm going to go 9 times 6 times 15 times 19 times 17 times 2. And we've got 523,260 different sandwiches. So, so literally they have hundreds of sandwiches to choose from. Well, egg on my face for doubting that. So, that's an expression, isn't it?
I've never heard of that.
Haven't heard of it before?
Is that including the breakfast and stuff?
Right, and then, see, I didn't even think about that. So,
yeah, you can get a salad.
but you know what? They don't ever give you, when they're doing breakfast, do they sell the sandwiches?
Yeah.
But when they sell the sandwiches, they stop breakfast?
Yeah. It's a certain time.
Certain time. So 10:30.
Well, I've been able to get a sandwich at like...
I've learned that 10:30 is whatever the person working interprets 10:30 to be. Because I've been like, I've gone, not talking about Subway, but maybe McDonald's. Like I've gone like at, 10:25. Oh, we're done serving breakfast. We're done for the day. Like, you got 5 minutes. What are you talking about? Or you can go one day and it's like 10:40 still, like, you guys got some muffins? Oh, yeah. Now they do it all day, so it doesn't even matter.
Yeah, I know.
But back then, they were like strict. Like,
Have you had their chicken strips?
no.
They're really good. They're good. Especially
At
the
McDonald's?
Yeah, they're way better than chicken nuggets by far.
Chicken strips?
Thank you. Thank you, thank you, thank you, thank you, thank you, thank you, thank you. So, you understand what's going on with the fundamental accounting principle?
Yeah.
If something happens a certain number of ways, something else happens a certain number of ways, they can happen together X times Y number of ways. Okay? Now, someone said, do you have like a formal definition? Yeah. It sounds like this. If event M can occur in M ways, and is followed by event N that can occur in N ways, then event M followed by event N can occur in N times N ways.
Wow.
Yeah. I actually had a professor when I was going to college that her and her buddy had a challenge, like, how many days can you go without wearing the same clothes? Yeah. And they used the fundamental accounting principle to figure out how many different outfits they could go.
So if you're not wearing one pair of pants one day, and then you're wearing the same pair of pants the next day, but you get a stain on it, does that make it a different pair of pants?
No, it's still the same pair of pants.
Like crisscross.
No.
Cut the legs off the pants and
But you shouldn't wear the same pair of pants 2 days in a row. You should kind of let them breathe.
Yeah, but other than
All right, so let's move on. Here's the other 2 things we want to talk about. Actually, before I go there, let's do this real quick. So I've been telling everybody, in the mornings, my wife makes me a licuado. I call it a shake, and I guess I was wrong because shakes have ice cream in them. It's a smoothie. It's a smoothie. We call them licuados, right? And it made me a licuado. And I love banana peanut butter in the morning.
yes.
So, what?
I've never had it. I want to try it.
So anyways, this is how she makes it. So she has the, no lactose milk because I'll get in trouble throughout the day. Yeah. And then some. But she'll put like almond milk in. So she starts off by throwing the bananas, and then she throws in the peanut butter. And then it gets all blended. And then she served it to me nice and cold because it's got some ice in there sometimes. Enjoy that. But one day, you know what she did? She put in the peanut butter and then the bananas.
And it got jammed.
And it was the same thing.
It probably tasted.
I said, oh no, you didn't.
It's banana, then peanut
It's
butter.
banana and peanut butter.
This is a peanut butter. That's a peanut butter banana. I like banana peanut butter.
There's like a PB&J, you don't put bagel for
You're one of those? I would just be sarcastic.
No, but it actually like pisses me off if I see people like spread jelly before peanut butter.
Oh, yeah, you
Who
should do
spreads
that.
jelly before peanut butter?
They're out there.
Yes.
All right, so anyways.
You ever pour your milk within your cereal?
No, never. Thank you. Thank you. Here's what happens when you go try to make math relatable. So, thank you. Thank you. Thank you. Thank you. No, I didn't notice a difference. Is there really a difference?
Yes.
No, there is no difference. Because everything is mixed together at the end. It's going to get blended. It doesn't matter. Don't be that guy. Don't be that guy. So, now, thank you. We realize that there are 2 camps out there. Those that say it doesn't matter, and those that say yes, it matters. Okay? So let's talk about that real quick. So we said there's 2 camps out there, right? It matters, and then there's those that say doesn't matter. I hope I spelled that right. Okay? So let me talk about this. Since we got 2 camps going here, here's what you need to know. If you are in the it matters camp, mathematically speaking, we're talking about permutations. We're talking about permutations. If you're in the camp that says it doesn't matter, then you are in the camp that is a combination. So make that note, please. Permutations, the order matters. Combinations, Order does not matter. Okay, write those down, please. Guess who's your teacher now? And then school yet. Yes, 11.1. Combos and permutes. Combinations and permutations. You will never forget.
I was sleeping at my sleep last night.
Yes. Alrighty. Can I change the slide? No?
What is that? Melonberry blue?
What?
Melonberry blue? It's freaking leaking.
We're good? We're good? Can I change the slide?
Yeah.
Alright, cool. Let's do this then. From this slide, this is a permutation slide. I need you to write this formula down. No, like a greenie. I need you to write this formula down. Now, this formula is for n permute r. And you don't read it, n! N minus r! That is not an exclamation point. We are in math world, people. That, what is it? This is called a factorial. That is called a factorial. That is not a point of emphasis. Now, if, no problem. So just real quick, thank you, Mason. If you have not seen factorial before, let me give you a quick rundown what it is. It pretty much is just saying you need to multiply the number they give you by every number beneath it. So for example, if you are given a calculation to 5 factorial, hey, calculate that for me, then that means you're going to take 5 times 4, not times 0. You stop at 1. Because once you throw 0 in there, then it's all gone. But, yeah, just counting numbers. Thank you. That's what 5 factorial means, okay? Do we have this formula? No?
Where's the exclamation point? Or the factorial?
Stop. Stop.
I can't see.
What if it's a negative?
Stop. There's always someone that's going to ask.
I know it's in there.
Where's it at?
It's on the board. Oh!
It's Pi Day.
This is a gift from Mr. Shapiro.
Can you do it?
No!
Why?
There's nothing in there.
So,
If we did break it, the candy would never stop coming out.
that was a terrible joke.
So we should break it?
You know there's only 3 candies in there, like a piece of one. Exactly measured out. That would be amazing. Hot water? In this slide, here is the combination formula. Red, and choose R. And choose R. I do want to point out the only difference between the two. No. Right there in green. It's the R factorial.
R exclamation point.
If you got rid of the R factorial, you would have the permutation formula again. The reason that R factorial that is there is to eliminate all the doubles that the permute guy says 2 different things. Peanut butter jelly. And you have peanut butter banana is different from banana peanut butter. That's permute guy, right? In combination, he doesn't care, so that extra R there gets rid of the copy. Make sense? You'll get rid of all the copies. because in his book, they're the same thing.
Mason, are you serious? I'm trying to contain this.
He's also human.
Who's human?
Mason.
I'm only human.
I'll say.
Where'd you get a letter on?
Mason's a foreign exchange student.
Stop.
Can I change the slide?
That's so gross.
No. Yeah. Guys, these formulas are also in your companion.
So this is for like the doesn't matter kind of people.
Right, here, order doesn't matter.
It's two scores. Put it back on his laptop. Why did you put it back on the laptop? Mason have to have water everywhere. Because ice melts.
Yes, that happens. Isn't that awkward? Unless it's in the Arctic.
Still melts.
Even in your freezer, they'll melt.
You know, it doesn't smell that much in the Arctic. It's just a wind blowing.
Thank you.
It's crazy.
Thank you. Thank you. So let's, just to kind of solidify combination permutation, I need to make a committee. And I need 5 people on this committee.
Okay.
And I choose my 5 people. Okay? Alright, Jennifer's on there. Does it matter if Jennifer got picked first or if she got picked last to be on this committee?
Yes.
No.
Yes. No, it doesn't.
Why does it matter?
Her confidence.
Why does it matter?
Because that means you're the leader.
No, it doesn't matter. Because it's one committee and they're all going to be in there. So if she gets picked first, third, or last, doesn't matter. She'd have the same capabilities as everybody else, same voice. It's just a committee of 5. Now, so that would be a what?
Accommodation.
That would be a combination. Now, let's say, how could I make this into a permutation?
Put
Not selecting
positions
her at
in,
all.
Like the chapter control and like
The NFL draft.
So yeah, so I can assign positions. The first person to get picked will be the president. Second will be vice. Third one will be whatever goes after that. I always don't know if it's like secretary or treasurer. Is it treasurer? So, difference? See it?
Yes.
Combos permutes. Okay. Now let's take a look and use some of our skills. Let's do some math, baby. This is an old 1912. Someone asking, how do you know? I don't know. I don't know how it's a 1912 license plate. So there's your 1912 license plate. And they want to know, by making this change, from going from 4 numbers over to 3 numbers, but 3 letters, how many more license plates I could print that are different. Well, for starters, we need to figure out how many plates we can make with that guy, right? So, if we take a look at this guy on this side, I've got 4 slots, don't I?
Yeah.
How many different numbers could I put in the first space?
10.
I could put 10 in there. I can go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10 different digits. How many digits could I put in the second spot?
9.
10.
I could put 10.
10.
What?
10.
Now, I'm going to slow down because I remember when I first heard that, like, okay, it's 10, 10, 10, 10, because I can repeat all the numbers. I can have a license plate that says 1, 1, 1, 1, right? So it doesn't matter that one got picked. I can pick that same number again. And that's where 10 to 10 comes from, okay? So that means that I can make how many different ones? I'm just going to go 10 to the 4th in my calculator. 10 to the 4th would give me 1, 1, 2, 3, 4. So I've got 10,000 different plates. That's a lot. Is it enough to meet what we need right now?
No.
Well, nah, especially not in Maryland, right? Now, let's take a look at the next plate. I've got 3 slots for letters, 3 slots for numbers. How many different letters could I put in the first slot?
26.
26.
25.
26.
It's all 26.
26. Awesome. Now here's how I'm going to punch in my calculator. I'm going to do 26 to the 3rd power. And I'm going to multiply that by 10 to the 3rd power.
Yeah, but
Go ahead.
you put the letters in the second.
No. It's going to be 3 letters and then 3 digits.
So how did?
It's all combinations.
How come?
Can't be like.
How come like the F that out, like it's not gonna count like 194 FAQ.
Say that one more time. Oh, no, that's the way they make it. They start with 3 letters, always, and then 3 numbers.
No, I know, but like the what do you call it? The equation, like it calculates that out. Like it won't do a set of 194.
Well, we're not even using a calculator. What we're doing is we're just figuring out, we're using the fundamental counting principle. I know that I can have 26 different numbers here, 26 there, correct? And then 10, 10, 10. So here's what I ended up with. I've got 17576, 1, 2, 3. That is a lot more, isn't it? So if I take away the 10,000 from the other method, 1, 2, 3.
That is same thing, just different.
No, that is about, it's only 10,000 less, so
Yeah,
this 7 became a 6. That's how many more? Questions? It's too easy? Like to hear that. Like to hear that. Yeah, so there was no formula used here. We just used our counting principle to figure that out, okay? All right, cool. Let's, now what if they had a plate that only used 2 letters followed by 4 digits? So 2 letters followed by 4 digits. How many plates could you make? Go.
So you have to do 2 26, 26, 10, 10, 10, 2, no, 2 letters, and then what? So 26, 26. That was literally what I just said.
That's still my answer.
What?
Literally what I just said, bro.
26, 10, 10, 10. There's no 26, 10, 10. I'm over it. Over what? Over it.
Over the hedge.
We need a calculator.
Mason, why don't you calculate this? No.
Yeah, I was doing it. Let me use my computer calculator. Wait, what? Munoz, 10 to the 4th is 100,000.
Joshua,
I got.
what'd you come up with?
I got 6,760,000. I got 6 million.
How'd you set it up though?
Oh, I just did 26, 26, and then 10, 10, 10.
Yep, 6 million.
Nice, exactly. And you ended up with?
6 million.
6,760,000.
Good, nice job. Questions here? Thumbs up, thumbs down.
I got it.
Thumbs, 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 thumbs. All right, cool, let's move on. This is so difficult.
Why do you sound like Eric Carter?
Okay, now, let me ask you this question. It's right up there. I've got 12 folders. I need to file them. How many different ways can I file them?
144 ways.
You got 12 folders.
Well, it's 12.
What? Why would it be 12 factorial?
Because like once you have them, you can't like duplicate it.
Yeah, if you have 12 files, 12 folders, and you're going to hang them, well, how many different folders can I hang in the first slot?
12.
I can hang 12.
11.
Then the next slot would be,
11.
and why 11?
Because there's one left.
I already hung one up, so I have only 11 to choose from. Then I would only have 10, blah, 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 blah.
6.
Okay? So this is simply going to be 12 factorial.
139 million.
Now, we know you don't want to sit there and do it, so where is that factorial?
I got the answer.
The answer is,
407.
thank you, I got one person. The answer is
Bam.
math,
Damn squad.
probability, and it's option 4, so you push 4. Well, make sure that you put your number first. 12, math,
Always put your numbers first.
not always. And there is how many? Whoa!
Holy moly.
Oh, it's not like I didn't say it 40 times.
Oh, no, I heard you, but I had to see it.
Where is it? You go math and then.
Math PRB,
Wait, you didn't even make all of it.
left to right.
That's why I'm trying.
This is why I don't like to participate. I'm ignored. Sure. Sure.
It's just 12 times 11.
Nice job, buddy.
You don't say. Times 9. You're so smart, Mason.
This is the probability of stats. Oh, you mean AP stats? Yes. Yes, it's a big block.
I actually think that you guys are really rude.
Alrighty. Cool beans.
I'm gonna fade all you guys.
This is the same question. This says you got 8 shirts you got to hang up. How many different ways can you hang them up?
8.
8.
Factorial.
Yeah, don't say 8!
Exclamation.
Alright, let's ask this question then. 10 students are in a race. First, second, and third places will win medals. How many ways can 10 runners finish first, second, and third? No ties are allowed.
It's 10 factorial times 3 factorial.
Okay, first let's decide. Is this a combination problem or is this a permutation problem?
Permutation.
Why is it a permutation?
Because it's a...
Alright, cool. So, let me show you this a couple ways. Thanks for closing your laptop. I'm going to do 10 permute 3. That means 10 factorial over 10 minus 3 factorial. That becomes 10 factorial over 7 factorial. Now, you could throw it in your calculator, but here's what you need to know. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Divided by 7, 6, 5, 4, 3, 2, 1. Question.
Yeah.
What is 1 over 1?
1.
What is 2 over 2?
4.
What is 3 over 3? So,
Can you cancel out?
that means that all of this and all of this makes 1. So you're just going to multiply
10 times 9 times 8 times
10
1.
times 9 times 8.
1.
Now,
Get the 1. It's just 90 times 8.
if you are Mason, you saw it different.
90 times 8.
If you're Mason, you saw it different. You said, hey, you know what? How many different winners do I get? How many winners do I get? I get 3. I get first place, second place, third place. How many people can win first place?
10.
How many options do I have there? Any of the 10 could win, right? Once I picked one, then I've got 9. Then I would have, and I would have to stop there because I have no more winning positions. 10 times 9 times 8. Go Mason.
720.
Yeah, so this would be, holy smokes. How many?
720.
720. 720 different ways. Yes. Not a stupid question. Go. N is your sample size. Statistics word. N is your sample size. How many you have.
Yeah.
And then R is going to be how many you're going to randomly select.
Yeah. Yeah.
Is how many you're going to get. Okay. Game marbles. And his sample size. Are we good?
Yeah.
Questions? Thumbs up, thumbs down. We're good?
We're good. Yeah.
Moving on.
Oh, write it down.
Hey, you know what? You can always go back and watch the recording.
Oh, should that? Okay, I'm done.
That was easy. Where's my button? All right, now this one. Oh, same thing. Same thing, guys. I got 15 runners. Finished first, second, third. And see how easy that is? You're going to see it in your head now, right? Oh, that's just going to be 15 times 14 times 13. Boom, we're good. All right. Let's take a look at this one. But wait, there's more. Now, here I'm not going to be able to give you a visual. Because the number of combinations that you can come up with is going to get ridiculous. Okay? So, here's what they want us to find out. They want us to find what 13 choose 4 is. 13 choose 4.
4.
Now, I can use my calculator. I can use my calculator to find this. This is 13 factorial over 4 factorial. 13 minus 4 factorial. That's just the formula, right? Notice there's an extra R in there because that gets rid of all of the doubles. So, here's what I've got. 13 factorial, 4 factorial, 9 factorial? Okay, cool. So in the top, I'm not going to waste my time. Once I get to 9, I'm not writing them anymore. No, I don't need to. Why? Because this 9 right here, this 9 factorial, is going to get rid of all those other ones. I do need the 4, 3, 2, 1. Now, let me show you how to make this simpler still. 4 goes into 12 3 times. 2 goes into 10. 3 goes into 3 1 time. That's it. So 13. It's just 1. You don't need to do that. Once it's 1, you're good. Thank you for the laugh. So 13 times 11 times 5. 13 times 11 times 5 times 1. As many times as you want. Go crazy. Go crazy. But get the first 3 first, okay? And then if you want to multiply by 1, as much as you want, you are good. I can't even move.
You remind me of like a park manager.
Thanks.
Like I can see you at Sunsplash.
What? No, I can't.
Like I can see him like walking around all mad.
What do you mean? This is M, this is R. Yeah? Well, I started with the top, right? So 13, 12. Yeah, I just cleaned this up. I cleaned this up because 13 minus 4 is 9. So that's 9 factorial. Then what I did is I stopped here at 10 because I knew that at 9, we're going to cancel all those 9s and down. Now, I could have canceled with the 4s, but then that would have left more work for me because then I got to go all the 9s through. So I eliminate, simplify, everything that I can first, okay? Now, that's what you do with the formula. If you have a calculator in your hand and you remember how to do this, then we're going to start with, I need you to have a seat and go around that way. Thank you.
55 times 13, but...
Okay. 13. Go back to math. Probability. Here is NCR. I can push number 3. And what was it, 4?
Yeah.
And then push enter. And there it is.
So how'd you get to this?
If anybody wants to know how to do that with Pascal's triangle, I can teach you that too.
I do.
That's easy. It just gives you.
It's too much. I typed in my 13, math, probability. All the probability stuff is right here. If you want to use all these other ones, take AP Stats. We'll school you how to use all the other stuff in here.
I'm not going to do that.
Smell you later.
Okay? Alright, moving on. Find me the value of 8, choose 3, please. 8, choose 3.
Can we do it your way? Or do we have to solve it out?
No, I'm doing it with my calculator. Now, let's see who's faster here.
No, it's loading.
No, stop.
What is it? 8. Math. 8. Math. Got it. Bam. It's so slow.
56 is the answer.
56.
Thank you. You just paused. It's one roll and he's across the whole room. That's great.
I got scared for a second.
That's amazing. I'm going to go back. We just want that over and over. My kids.
What was better basketball?
Where's Chase Elliott's
Double check that you got 56. Double check that you can get 56, please.
I know.
It's a what? It's just supposed to be me in the shot. It is very low quality. It's like a $50 camera.
It's like,
What's the quality?
My camera. Yeah, it almost feels like the old days when we had analog TV.
Is it on?
Yeah. Okay. Thank you. Let's go back to figuring out whether we're working with combos or permutes. Example. A chemistry teacher divides his classroom into 8 groups. Each group submits one drawing of the molecular structure of water. He will select 4 of the drawings to display. Is this a combination or a permutation?
Permutation. It's a permutation.
I like the word.
It sounds really good.
It's a permutation.
Combination? Show of hands. Permutation?
It's a permutation.
Oh, it's not a permutation.
What did I say?
It's not. Is any one of the groups winning anything special in this case? They're just going to get put on the wall, aren't they? So does it matter if you got picked first or last? Not really, because you're still going to go on the wall. Okay? Now keep that in mind.
What if we want to be first in
Well, then you would have to make it a competition, wouldn't you?
Yeah, that's true.
All right. Determine whether you should use a combo permute. You will draw winners from a total of 25 raffle tickets. The first ticket that wins gets 100. Second one that wins gets 50. Third one that wins gets $10.
So it's 25, 24, 23.
You see the difference? It's pretty obvious, huh? This is a permutation. Now, let's change up that chemistry teacher a little bit. You guys ready?
Sure.
A chemistry teacher divides his class into 8 groups. Each group submits one drawing of the molecular structure of water. He will select 4 of the drawings to display. How many ways are possible for the teacher to select and arrange the 4 drawings from left to right on the wall?
So 8 groups. How many people are in each group?
Well, he's doing the same thing.
But
So he's going to collect them all, right? Now the question is, how many ways are possible for the teacher to select and arrange the 4 drawings from left to right? Combination, permutation.
I think it's permutation because you make it almost like a competition.
No, it's both.
Well, it does.
They all.
It's neither.
Wow.
Oh, a combination.
I say.
They just end up.
It's fermentation.
Parmesan cheese.
Yeah.
Parmesan cheese.
It's not.
It's fermentation.
Oh wait, yes, it's permutation.
Why is it a permutation?
Because they were like 4 drawings. Yeah.
He wants
So
to
it's
know.
not because she's gonna take them out of the group.
I'll be like,
It doesn't matter.
Does anybody win anything special here?
No.
well,
$100.
they get their
Hold on.
put on the wall from left
I
to
hear a
right.
yes.
Yes.
Yeah, because they get picked out of it.
Well, the last one we did, they just got put on the wall, right?
Yeah.
But they did
They got picked.
Yeah,
It was still a combination.
everybody got picked. There's 8.
No, there was 4 drawings that got picked as well.
Yeah, but that means making it left is the best, the right is the best.
Well, he didn't say the best. All it says is they're going to put them on the wall from left to right.
So it's combination. Nobody cares.
Okay? It's a good question, but it really just is a permutation kind of thing because it's more of a counting principle type of thing. How many is he picking? He's picking 4, right? And he's going to go like this, just like this, left to right. Once I have my 4, how many can I put in this slot?
4.
How many can I put in this slot?
3, 2. Oh, so everyone gets picked.
No, there's 8 groups.
Oh.
Okay, so how much is that?
4, 3, 2, 1.
4 times 3 times 2 times 1. That's how many different ways there are. Okay? Yeah, because it says the chemistry teacher divides his class into 8 groups. Each group submits one drawing. He will select 4 of the drawings to display. So if he selected them and then it says how many? So yeah, that would be it. Unless he has all of them and then says I want this one here. Do you see the difference there? Here he selected them first, right? So he already has the 4. If he has all 8 and then he's deciding from them, then it would be a different case where it would be an 8, 7, 6, 5. If he's not choosing beforehand. So you gotta be careful with the way it reads. Guys, that's all I've got for you.